He's gurgling in there. How we doing? How's everybody today? Okay, I'm gonna let Zoom take attendance. Having a hard time trusting it, you know, trust issues and all, but we'll do it. So make sure you're in the Zoom session because I'm gonna let it take charge. Get everybody admitted. It's hard for me to relinquish control in some areas, but I can do it. It'll work. So if you saw on Discord, I posted some Zoom just etiquette rules. Try to use the participants screen and give feedback and responses. Since more and more of us are going to be working remotely, we want to use those tools, make sure we're utilizing the features, communicating as much as we can. I'm going to shut this off. Don't have any pretty background music. And let's look at what we got going on. We're ready to look at Windows Communication Foundation. This is our last thing that I'm going to really give you any sort of information about demonstrations or anything. So this is kind of our last week where we'll be doing new things. Next week, you will have some new concepts that will build on WCF that we're looking at this week. But there's some online training available, and I'll just leave you with those so that you can work with them. We will be getting together though, yay, to get ready for the MTA exam. So we'll be going over the study guide material each day that we have left of the semester. So if you look at our upcoming schedule, next time will be a group project lab day. And so again, just like our other lab days so far this semester, you can either come here and work or work at home. I'll be available for questions since this is your group project. Make sure you're kind of all in cahoots about what's going to work best for you. Some of you I know have group members that have to be at home, so for different reasons and things like that. So I know we'll have to be flexible with this group project. You guys have such outstanding skills that you've developed this semester. I don't have a lot of you here. I would give you good eye contact if I had the camera on, but I'm just like you and would rather have it off. So anyways, you guys really have developed some outstanding skills. And I think you're going to be able to pull this group project together pretty well in spite of all of the obstacles that you're going to have to overcome. And I think that's pretty amazing that you guys are going to be able to do such a great job with it, considering what you've had to deal with this semester and last semester. So wow, you guys are just doing an awesome, awesome job. As I look at things, I'm just so happy with you. Now, some of you, of course, have some weak areas. As we go through and look at our MTA prep material, that'll give you a chance to kind of refocus on some of those areas, maybe do a project or something that you're missing, or even just some extra practice so that you feel more comfortable with it. As we go through the MTA prep material, you're going to see that the experience you have, the projects you have done, have you very, very well prepared. So it's not the kind of test where you're going to feel like you need a practice test or a study guide. You've had the experience and it's built that knowledge for you. So as you move into the exam, it's probably going to be a pretty natural step for you. We have the group project and the final project, so that does seem like a lot. Remember, we have like 2.5, 3 weeks to get all that done right now. So we're looking at quite a bit of time. So as you work with your group to get that group project done, also have that final project started. You may need to switch back and forth, switch track if you can, kind of decide how things are going. Now, let me make sure, as I mentioned that you guys can see everything. Can you see everything? Yes, sometimes I think you can and you can't. So we have some things that are showing up in Canvas that you can look at as you have time. We won't really talk about them in particular today. We'll wait until we start with our MTA prep next week to really look at all of the resources that are available, but you're welcome to kind of look around. Your final hands-on project is Jeopardy, the game. So you can use, all sorts of different design ideas. I've seen so many different ways of doing it as to how you handle the whole game, how things are, how it works, how people enter responses, all those kinds of things. So using Windows Forms just gives you so much capability with creating that Jeopardy game. So I hope you have fun with that final project. It really is a good one. So we want to get with our group project. And before we get into it, I think we're best off if we start looking at WCF. And then after we've looked a little bit at WCF, the group project will make more sense because it's kind of dependent on that. So I'm going to grab this PowerPoint in lesson 14, the WCF overview. Let me see if I can find it. I think I have it right here. Okay. All right. I'm going to check one more time. The version of PowerPoint that I have on this, instructor machine won't let me do where it interprets words down there, so I apologize about that. I need a different computer, the narration. All right, so Windows Communication Foundation, WCF. That's what we're going to be looking at in this chapter. And I know you're getting acronymed to death. That's, you know, the part of being a developer. You get a lot of TLAs, your three-letter acronyms. And with C# and Visual Studio, it seems like we have more than our fair share, especially as we learn about the different capabilities and different services available. So WCF is a web-based service, and it allows us to create like application programming interfaces, like connection points that other people can connect to run code so that we can have an event occur or something specific happen. So this lets us, by using WCF, we can have consistent internet-based communications. We'll talk about that. And in the past, way back, we had to have different methods and protocols for different platforms if we wanted to communicate. But WCF kind of gets away from that and offers us a unified platform. There's a lot of good material in chapter 23 of your C# Pro book about using WCF. We'll be looking at a different resource for our demo today so that you have multiple sources for looking at information. Now, one place that I think of right away when I think of an application programming interface, an API, is using an ATM, right? So I can go to my bank. I have UMB, and so there's only like one ATM in town. I don't know why, they just don't have very many. So I could go find theirs, and I could use it, and I could take money out. And of course, it's using a million APIs behind the scenes to do that. But, you know, I know how to use an ATM. But what if I'm traveling? Can I still use my debit card, my UMB debit card? I'm going to get charged, right? But yeah, I can, because those same APIs can be utilized wherever I am. So no matter what kind of system I'm using, which in the case of our thinking might be an operating system, but no matter what kind of system I'm using, I can still utilize the UMB services to give me my money, right? This bank in France or whatever is going to be able to make calls, application programming interface calls, to find out if my account is valid and if I have enough funds. And it's going to be able to do those in a standardized way across the internet or some sort of communications channel. And that's all because of APIs, all those interfaces. Now, when we look at WCF as an API builder, and a place that gives us that capability, here's a good picture of how things will work for us. We have a web server here. This web server could easily be hosting a website or a bunch of websites, but it can also host some specific services, WCF services. In this particular web server, we see that there are two endpoints or two APIs being hosted on this server, WCF number 1 and WCF number 2. Both of these things access information at our corporate location that has to be maintained there, like trusted people and, you know, personal information and things like that. That's why we have these WCF services set up. We can call them no matter where we are, but also we can use our private information if we want to. Then we can have clients out here in the field that are connecting to those services to update information specific to their location. So we can have multiple clients call in basically or make connections to our services to get their information. In this kind of example, we could be doing something where we're keeping information in sync, you know, kind of like OneDrive or something like that, where we're keeping track of updates and making sure that each client has their own data stored at their site. A way we could think of doing this, one company that comes to mind would be like, just Come and Go or something. Some of them, I guess Walmart is a good one, right? Walmart is famous for letting Bentonville control the temperatures of the stores, or I don't even know, I guess lighting and all sorts of things here lately. So they could actually have a WCF service here that allowed a store or a store's thermostat or HVAC system to connect to the server to find out what the required setting is for that store. And then that way, the administrative support in Bentonville can keep those files up to date, that database, and say, well, store number 57, they're always complaining about it being too hot. So we'll give them an extra degree of coolness, and we would be able to have that information stored centrally. If we think about other things that are more normal at Walmart, it could be pricing information, right? That maybe when somebody scans something, that product can't be found in the local files. So we could make a call to the corporate files behind the scenes and find out what the default price is for that information. For your group project, you're going to create a WCF service that's going to be like your UPS or FedEx or something. You're a shipper. And so your server is going to calculate the cost of shipping a package. So your client application out here is going to ask for information about the package, name and address and how big it is and things like that. And then it's going to connect to your WCF service to find out what that shipping cost would be. And that's pretty standard with UPS or FedEx. We could even download information from them about how to access their APIs if we wanted to include that sort of information on our applications. Okay, so some things about WCF behind the scenes. There's a lot of information, as I mentioned in your textbook, some really good stuff. There's a lot of acronyms. Basically, WCF gives us the classes that allow our methods to be called from other machines. Because we're using a network-based communication interface, we have to agree on some common data formats and protocols that we're going to use to communicate with those other machines. We have some standard ones. We've seen a lot of them already in class, and some of them you've seen in your web dev classes. XML, JSON, HTTP. These are all communication protocols and data protocols that we've seen a little bit or heard a little bit about. All of these things have to be specified when we create our service. Which of these formats and protocols are we going to use? How are others going to connect to our API? Now, our class, like we mentioned earlier, is saved or running on a machine, our web server, and then all of our clients can now access this server. It does create a basic API and application programming interface. And it does give us distributed capability. Distributed capability meaning I can be running my client and my server at the same location, or I could be running my client and server at different locations. They could be distributed across the globe. Either way, my communication is going to occur over the internet or using internet-based protocol. Now, some things that are important. This is a message-oriented programming. Our client is going to send a message to our server API. Our server API will send a response back. So that's why we have to specify what our data formats are going to be and our connection protocols so that we know how those messages can be sent and received. Some over the network call implementations that we have available to us, different protocols for making these data message transfers. SOAP stands for Simple Object Access Protocol, and this is XML based. So we have an XML file that describes how the requests and responses should be sent and received. We're going to look at these when we create our application. When we're using SOAP, we're using common IP type protocols like HTTP, port 80, and we're using standard XML-based formats to wrap our data in a message. So SOAP is just going to be the thing that puts a header and a trailer on our message and kind of wraps it in something so that it knows how to be handled at the other end, kind of just like a nice tunnel for us. And then REST, representational state transfer architecture, gives us more of a request response type mechanism where we can say, hey server, I have something for you, and the server can say, okay, what is it? So we have some get and post syntax. When we're using REST, we don't have XML data wrapping involved in our messages. We have a more specific syntax that is used behind the scenes there. The get allows sending of plain text like our URL, and the post is kind of embedded in our communications. As you can tell, we'll be looking a little bit more at the SOAP implementation. But that's a decision that has to be made along with all of the other design decisions that have to be made as you're creating a new application. When you're decided that you want to create a web service, first of all, you've already had to kind of come up with some design architecture decisions. Let's see, they say we're going to use a web service when the boundaries of our function are explicit. So that means that we know exactly what kind of data we're going to send and receive. We're not doing any sort of major user interface type activity, just some data. These services that we set up with WCF should be autonomous. That means just kind of an island unto themselves. So again, if I'm wanting to check to see what the current price is, that island is just the price just for that product. And I can isolate that down and say, yes, I can make that a web service because it's completely autonomous. It's not dependent upon anything else, right? You give me a product code, I can give you a price. Our services are going to communicate via contract. So that means that we can identify exactly, again, what's required, what has to be sent and what has to be received, and what architecture for communication and data transfer should be used. So if we meet all of those requirements and we've decided we're going to create a WCF service, there are some things that we're going to need to be gathering. When working with WCF, one component or item of information that's going to be important to us is the address. This is the location or web server URL, basically, of our server. It's considered an endpoint. So when we have our AWS web server, I gave you guys the long URL that we use to connect to that, and that's the endpoint for that AWS service. So any sort of web-based service like that that we can interact with or connect to is usually going to have an endpoint. It usually includes the protocol. So here's an example one of an endpoint address. Here we're saying that I want you to find the file myservice.svc in the folder myservice on the server myserver within mydomain.com using the HTTP protocol. And so that URL is specifying all of that information, what protocol I'm using, what SVC file I want opened on the server side. So I'm basically supplying all of that information in that endpoint address. Now, besides the address, we need to be aware of our bindings. How is this client going to communicate with this service? Are we going to use SOAP or are we going to use REST? We could make our service multilingual. We could handle multiple protocols if we needed to. So of course, just like everything else we've learned in C#, if we came up with an obstacle, we would figure out a way to overcome that obstacle. Lastly, with our bindings, we need to consider security constraints. Are tokens going to have to be passed to validate some sort of identity, or are we just going to assume that a connection involves access? And then contracts. Our contract is basically the interface that exposes the web services. So looking at this previous slide, that would be the .svc file in effect. That file exposes all of the endpoints for our service. So we can say that our service can connect to all of these clients using our endpoints. When we create our application, our service is going to be running on the same machine as our client. So we're going to be kind of emulating having this web server. So be aware of that. Anytime we start doing applications like this, development like this at the higher level, we are running into multiple platform issues and different things that could interfere with our execution. And we'll see that we could definitely encounter those. Now, as a client machine, we're going to consume that service that's offered by that server. So looking here at our little picture, here's our server application over here with all of its endpoints. And over here on our client machine, we have all sorts of different options available to that client, some of which create connections to that server. But our client is basically sitting over there using those services as they're needed. And behind the scenes in our code, we're going to make those connections to the appropriate endpoint and basically run, a function or a method on that endpoint. Now, whenever a client requests a service, the server is going to respond with the information that's required to bind to it, whatever protocol is in use, all of that kind of information. The client is going to respond, and then the server will respond okay, and they've made that little handshake. They should be ready to communicate with each other. Whenever we're sending messages via the internet, via some sort of network transmission, we always have to be concerned about the network stack. And that means that when we issue a command on the client side, there is going to be some processing that occurs behind the scenes in that network stack. First of all, they say right here, we're going to have some serialization occur, some sort of bundling of that data. Then it's going to go through different operating system functions to package the data to make it ready to transport. Once it's finally packaged up and has all of the appropriate information added to it, what's the IP address of this machine, where is this machine located, all of that kind of information, those packets can be sent across the network. When they're received by the server operating system and network stack is going to have to reassemble all of that data, strip off the addressing information, packet all the data back up in the original format before it can be processed. So even though it looks like this message just goes directly from the client to the service, we need to be aware that all of this protocol processing is happening behind the scenes, because we can have, as I mentioned earlier, a lot of different areas where we could potentially have an issue. So we have to be aware that all of those things are happening behind the scenes for us. When we're working with a network implementation like that, a distributed implementation, we do have a lot more complexity. All of those network protocols and stacks and addressing information can really make things more complicated. So we have to have some benefits to make it worth it. We think about the benefits, they're pretty big. We can access our data from basically anywhere. So we can have a mobile application that interacts with our API. We could have, as we saw, an ATM that integrates with our API. So It allows us to let our data be accessed. We could perform complex computations in our service so that we don't have to have those computations being performed out on all these other client machines. Maybe we don't want that code downloaded to every machine that we interact with. Maybe we have to be sure that the operating system that's running can handle these computations. So we want to control that. We can do that because we're running that information on our server. In the same way, we can make sure that we're using valid data. Our server is controlling all our data. We know where it's coming from. We know where it's going to, so we can make sure it's actually valid. But the most important thing is we could have multiple clients accessing our web service. So we could have, as we mentioned before, all of our retail locations accessing a service to see what price changes have occurred. We could have an update running through one web service. We see a lot of capabilities there. So we're going to create one. Let's create one. I'm going to take this, get rid of this. So the thing that I want to use to create one is this PDF document that's attached to Canvas. So like I said, your textbook has some really good examples. This one is a little bit more concise. It is also a little older though, so we hopefully won't run into any version issues. I'm going to go ahead and download it. You can see this is kind of just a web chapter, and they talk about a little bit about all of the different formats for different messages, and then they get into creating a WCF service. So that's where I want to pick this up. Now we're going to try creating this using Visual Studio. I did is a heads up, see something somewhere that said we would have to run Visual Studio as an administrator. I have not encountered that, but we'll keep our eyes peeled to see if something pops up that makes us think that could be a problem. Just be aware of that. I'm going to run Visual Studio regularly, not as an administrator, and we can sort of switch if we need to. Now we'll be using, because I said, a different version of Visual Studio. So I want to create a new project. And I imagine I could just search for WCF up here in the templates. So we have some different choices here. Our WCF service would be a base template. Our service application kind of gives us the sample project, and our service library would be a project for creating a DLL library. Let's do the middle one, our WCF service application. And let's see. We're going to build this one. It's going to be Welcome SOAP XML Service, and I'm going to name it that. So that our application will match up with their examples. That should be everything we need. We'll go ahead and create it. So the first thing that we should look at is our, what do they say? we want to look at all of the kinds of things that they created for us. Let's give it a second. That SVC file from the presentation, if you remember, that's kind of the file that has all of our service information. If you expand it, you'll see that it has a code behind file, .cs file, and that's what I'm actually looking at here. So in our service1.svc file, we're going to see some information. Let's take a look at it. Notice that it inherits from iService1. Let's look at iService1.cs, our interface. In our interface, we specify the actual contracts that we're going to offer up for this service. Notice the badges that identify what kind of contract each thing is offering up. Our interface name, iService1, is the name of the service contract. We have an operation contract called Get Data. So in a normal interface, like we had created earlier in the semester, we would just have our interface name, and then we would have our method header, right? And this would say, any class that implements this interface must have a method called Get Data that returns a string and accepts an integer in value. So if we kind of think back and refresh our memory, that's what an interface says, right? It enforces that this method must be implemented in any class that inherits or implements this interface. So we've just added a little bit to our interface with these contract badges. So now we're saying this interface, iService1, offers up an operation named Get Data. That's the contract that it offers to clients that connect to it. So we have those two levels. Our services, this is a service, and then the operation this service offers, like Get Data. Now, whenever we look at this method header or Get Data, again, it's going to return a string and it's going to accept an integer value. We have another operation contract in this interface, and it returns a composite type, and it runs this method Get Data using data contract, and it has a little bit more information. It's a little bit more flexible of a method. Now, this interface shows these operations as operation contracts that are available. Below, we see the actual data contract, which is just our properties, right? So we could have properties for Boolean values or string values in this interface. We have some default values set for them. Let's take a look at our web.config file. In our web.config file, we see that we're specifying information using an XML type format for whether we're going to allow HTTP GET, HTTPS GET, what kind of interface is going to be allowed. Let's take a look at what else do we have. That's it, pretty simple, huh? So, oh, okay, sorry, Rich. Ah, you see why you can't find it. Is anybody else having trouble? Sorry, Rich, I wasn't watching the chat as good as I should. You guys yell at me. Is anybody else having trouble finding the WCF stuff? Sometimes it can get us. Okay, we have some people that are installing it. Let's let that happen for a minute or two. Are you guys finding it okay? It's not giving you any trouble. Erin, what kind of trouble are you having with Visual Studio? Break it. Remember, if you're at home, or when you're at home, do file, is it account settings? Make sure your product key is applied. This is the time of the semester that if you installed a like a evaluation license, your evaluation will be done. So, oh, look, that is what Erin's trouble is. Okay, so this is the time of the semester that if you did not enter a product key when you installed Visual Studio, you will now. So what do we need to do? Let's review. We can handle it. Because it'll probably be happening to quite a few people. I'm going to search for dev tools for teaching. That'll work, or learning, either one. Now, Dr. Ford has this link posted, and I have this link posted, and you can find out everywhere. Or you can just search for dev tools for teaching, and then you can find this Azure for Education. And then sign in. And remember, mine doesn't work. I'll try it. It'll reject me. I have to use like my personal something account. It's got it all mixed up. Okay. They said my OTC account wasn't secure enough to have access to this, so I could only use my Outlook. 2.8. Don't want a dash. Oops. I was using the number it came from. Like I told you, it doesn't like me. So hopefully you guys are able to get logged in and find your Visual Studio under software and find your product key and get all of that taken care of. I'm not going to mess with it today. So I've got other things to do. Make sure you get those product keys. How you guys doing? He's got the link. While we're looking at all of that, I posted a URL to the Discord channel. Erin had posted a cute meme about regular expressions, and I wanted you to see that if you're a Linux person, that regular expressions are really heavily used in Linux, and so you can use them in grep and a lot of fancy utilities pretty much just the same way as you've learned them, so that's pretty neat. Okay, how are you guys doing? How are we doing? How are we doing? We want you to play with us because it's just so much fun that we don't want to miss out. Everybody's getting there. So fun to work from home. I took an image of my machine last night, so now I'm really worried because I don't know what in the world made me do that. It means something bad can happen. Yeah, you can't see this thing at all. Sorry about that. Poor tech staff gets it all fixed, and then whoever messes it up comes and messes it up. The resolution on this screen has to be set really low because of all of the, they have like 57 different connectors and gender changers and adapters between this thing and this thing. So I think it can only do like, I don't know, 1024 by 768 resolution or something because it's got so many different pieces of hardware in between. Okay, how's everybody getting? How we doing? Let's see if we can get this thing running. We've looked a little bit at the code behind the scenes here, and we see that our interface is specifying what operations can be performed by clients. So can we run this thing? Let's run it. Notice up here at the top it says IIS Express Google Chrome. Does yours say that? Good. Let's make sure everybody says it. Did you get this? We could have gotten something different. Now, this is just obviously a folder listing of my project folder. That's not super helpful. The way that this is set up for us to be able to run it within Visual Studio, as I said, we're simulating being a server. We have to be looking at the .svc file. Visual Studio isn't usually like that. Normally it'll figure things out. But for this, for WCF, we have to actually have our .svc file open. And then let's try it. Then we should see the WCF test client. So this is one of those little things, right? One of those really little things that makes it hard to do things with the book, because that could be one that can take an hour or two. You're not understanding what's wrong. All right, so this is really cool. This test client shows us then that our service is named iService1. That's what our interface name was, so that makes sense. And within our service, we have a get data method that's available. If I double click on that, it'll actually start allowing me to test that method. And let's see, right now, it says that we have a value of 0. I'm going to invoke. And I get a return back that says you entered 0. So this used that get data method, and the result that was returned by that get data method was a string that said you entered 0. Let's change our value, 5, and invoke our method. And now we get back you entered 5. Okay, so this test client just gives us a way to be able to test our service. Let's look at the get data using data contract method. This is another method that was set up. It's got a false is a Boolean value and null is a string value. Let's invoke it. I'm not sure exactly what it does. We didn't look at it as much. It just kind of returns whatever we sent, apparently. So we could try our different methods. So the test client just gives us a way to make sure that our service is running, but it also gives us a way to run our service like we're a web server. So not only can we use this test client to test our service, we use this facility to have our service running. So now that my service is running, up here where my address is, http localhost :port number 58865/service1.svc is my address now for this service. So that's the current address. That's not a permanent address, is it? Because hopefully someday I'll install my awesome web service on a web server, and then I'll have a more permanent address. But for right now, this would be the address I would use to connect to this service if I were to create a project that was a client. Yes, we created a WCF service application. Let me make sure that there wasn't anything else weird. Yep, we did WCF service application. Do you have these same templates? So yeah, this one in the middle. And you're using 2019. Can you show us what you have? Oh, okay, let's see if it. Okay, I'm gonna stop share. Okay. Does it work? Cannot share. Okay. Aaron, is yours working? My son said his professor that he works for gives people 6 seconds to respond in Zoom. I thought, man, how does he spend all that time counting? I'm still trying to remember what I'm going to say. I don't think he's showing complex coding things. He's just lecturing. All right, Aaron. Okay, we're going to test now. So we know that we've got this address. This is our endpoint address for our service now on our local machine, our local host machine. So let's create a client. We could create a client project. I'm going to close this for a moment so that we can go back to our project. There's a couple of different ways we could do this, right? Just like everything else, we have a lot of design choices. For our testing purposes, we could create a whole new solution project, everything as our client, and that would be pretty realistic, right? Because our client is probably going to be a completely separate solution from our server. If we do that, we'll have a little bit more configuration issues, challenges, than if we create a project within the same solution. So in order to kind of limit our configuration challenges, we're going to create a new solution within, or a new project within our current solution instead of a whole new solution. All right, so I want to create a new project. Now I'm going to look over at that PDF and make sure that I don't do this improperly. So it says a net web service client can be any type of application, like a Windows application, a console, or a web application. So let's create a Windows Forms app, because that's what you guys are going to be creating. It's your group project. So in the C# Pro book, you'll see there's the great examples that are kind of console based, but let's create client SOAP XML. So I'm just going to say client SOAP XML because he is not offering a service because he is a client. So I'm going to create him. So my form, I'm going to give it a text property that says WCF test client. And for our test client, let's create a label that says data to transfer to service. And we'll put a text box by that. And let's name this one TXT BX transfer to. And then I'll put another label on here and make this be data received from. And then we'll put a text box. And we'll name it TXTBX received from. And then we need a button just to make the magic happen. And just like they did, let's call it invoke. Oops, wrong place. BTN invoke for its name and invoke for its text property. So we're ready. I mean, we're just going to put some code in here in our button to make it call our service. So let's make that connection. We want to add a reference in our client. So up here in our client, let's look at our references. We don't want to add a regular reference. We want to add a service reference. Now, the best thing for me, though, is going to be for me to get my service running. But let's choose add service reference, and let's see if it can discover our service reference. Oh, and indeed it did. So since we're in the same solution, the discover button was able to find our SVC, our endpoint URL, and pop it straight into our application. So that's good. We know where the service is. If we expand this, we see that our service has get data and get data using contract, those same methods that we were seeing earlier. So that's our service reference that we need to add. Let's click OK. It found that endpoint address. Now you should be able to see in Solution Explorer that we have this new connected services component in our client, and we have our service reference. And we would need to access that if we needed to update it. So notice by double clicking on it, it's taking me to the object browser information for that service. I would have to right click on it and choose update if my service changes and I want this client application to be aware of those updates. Okay, so now we've made our client application aware of our server service. Let's put in some code to make it use it. I'm going to double click our Evoke button to add some code, and let's see. They've got all sorts of crazy stuff in here. We need to declare a reference to our server. They make it private in their example, which is fine. Service reference. And then we want to use our client. And we're going to name this instance of our service a client, or client will be its name. Okay, that sets up a variable or an object for our instance. Let's instantiate it. We could do it all in the same thing. Oops. What have I got wrong? Doesn't like my reference. I was trying to do that global type stuff for class level, making it mad. So let's just use that thing. My client then is going to be a new instance of our service reference. I wonder if you're missing, what you're missing, Rich. Do you have Enterprise Visual Studio? Okay, so I've got a new instance of my service reference. So we should be able to say that our text box received from .text, we want to set that equal to whatever our client returns from, which one do we want? Get data. And we have that text box set up, transfer to, but we're going to need to convert that to an integer to be able to transfer it to our service, since our service is expecting an integer there. Okay, so we're going to use our transfer to text box, convert it to an integer, and use that integer as a parameter or an argument to call our get data method. Whatever our get data method returns, we should display in our received from text box. Let's run it, see what kind of mess we have. First of all, I'm going to change my startup project because I just want to start this as a standard project. so it's working, because everybody's working. You should not need Azure development installed, Rich, I don't think. Working? Working? You guys have communication going on? You don't even realize how awesome it is. It would be so much better could we communicate with each other via the network and kind of send and receive and stuff. We need all sorts of fancy web servers or something. That's what I should ask for C# too, right? We need some AWS web servers so that we can do this stuff here at the end. But it's just like 1 or 2 assignments, but it's still very important. Very high level stuff. Okay, well, I hope that you guys are getting something here. We have some people at home that are struggling with their Visual Studio installs, but that was a great time for me to mention to everybody to enter their product key. And other than that, like I said, do a backup, you know, like an image of your machine right now. This part of the semester, don't update your machine. I was going to buy some memory, you know, and I will today. I'll buy some RAM. And RAM is a super simple upgrade, right? It shouldn't cause me any trouble on mine. I mean, my gosh, it takes like 5 seconds. It won't do me any sort of problem. Wrong. I've watched enough teenage boys destroy computers by trying to install RAM to know that anytime you open your computer, you're risking something. So don't do those kind of upgrades while you're in the semester. Wait a couple weeks until the semester's over, and then that's the time to open up the computer if you have something new and you want to put it in there. Got a new SSD? Wait until Christmas breaks to install it. Don't put it in right now. You're always risking everything, and I love all those emails I get. My computer is broken. Oh, bummer. What are you going to do? All right, so this is awesome. How do you mess up RAM sticks? Oh, Jacob, let me tell you some stories, sir. WCF Service 1, your namespace. You're running Visual Studio 2019. Yeah, static electricity is a big one, Aaron. And especially around here and in the winter when people are so used to not having any trouble with it that they don't worry about it. Another one is just not getting them seated properly. People, it's amazing how many people will get them partially seated and then they'll push the little latches up themselves because they're like, oh, I just push these little latches up. And of course, RAM isn't really fully seated unless the latches snap up on their own. So that's a big thing. So no, I'm not going to touch mine until Christmas break because I know that I can't see very good. Or if you have carpet, yes, that can be a big one. I had a student when I first taught PC maintenance who had opened up her computer many times in Carthage, in Missouri, in Southwest Missouri, where our humidity levels are really high, in her living room and all over the place and never had a problem. And then she moved to Arizona, and the very first time she opened up her computer on her living room floor, she fried her RAM because she got a serious static charge because there's not as much humidity out there. So let's see what we can do. Microsoft Visual Studio Enterprise 2019. You can see I'm just not very good at that. Where is it? That should be working, Rich. We'll take a look at it here after we get everything going, see what's going on with it. If you had to uninstall and reinstall, I hate to say it, but I think you should restart your computer. I hate to be that person. But let's add a new operation contract. This was all great and good. We use this default service, which is fine. We can do that. But I'm going to ask you to do something a little different. So let's try it. I want to create a new method. So I'm in my iService1.cs file of my service. And in order to create a new operation, I'm going to copy the operation contract badge and the get data header. And I'm going to change this to say hello And instead of having a integer passed in, I want a string that will be their name. Okay, Isaac, hang on just a second and we'll look at it. So come with us and update this service, and then we'll get your form all set up. So my new method is going to be named Say Hello. I want them to pass me their name, and I'll pass back a string that says hello. I don't really need to add any sort of data types to those properties. But what I do need to do is add my Say Hello method. Well, it's in this code behind file, our service1.svc.cs. We looked at that kind of quickly, but I sort of just glanced at it. Now I've got an error, right? That's because my iService, my interface, now says that I shall have a method named get hello or say hello, and I don't have that method created. So that's why I'm in error now. Well, I wanted my method to be kind of like this get data method, so I'll copy it. And my method name is going to be say hello. And it's going to take a string that I said was going to be called name. Now, what I'd like to return is something that says hello. Hello, comma, your name. That should do it, huh? That should be all we need for that method. I think that gives us everything. I can go ahead and test, though, if I'm not going to fight with the configuration manager. I'll just change this to be my startup project, my service, so I can run that WCF tester. Whoops, I did that again where I'm not on my SVC file. Where's my SVC file? There it is. And I want to be sitting on that when I run, so I get that WCF tester. And now I should see my new say hello method. So I'll put in my name and invoke. And I should see my hello response. You guys okay? That work? Work. All right, so let's go back to our client. I'm going to change my startup back to my client. And then in my client, look at my code for that button. And right now, we're using our client and we're calling the get data method. Let's change that to use our say hello method. Shouldn't our say hello method be showing up? Why would it not show up? We've got to update our service reference. And now we should see our new method, say hello. Because I don't need an integer there, I'll get rid of that convert to int. Not to be the code you need, Isaac. Now, we should, if our form is set as our startup project, we should be able to run, should be able to put your name in and see that hello message returned. So we saw a couple weeks ago that we could create web-based applications using ASP.NET. This gives us kind of that back end where we can create web services that aren't really involved in the client per se for that back end. I'm going to go ahead and start this. And I'll put my name and invoke, and I should see my response back. Awesome. Okay, so as soon as we look at the requirements for the group project, then we'll resolve any sort of problems or issues that anybody's having. We can figure all this stuff out. I say when we start getting to our more advanced things, whew, it can be interesting. I'm always like relieved if something works. You guys just don't know. A lot of colleges and community colleges would just gloss over these kinds of things or not actually have you do anything with them because it's can be kind of difficult to coordinate, but we can handle it. So I want to look at our group project, and I'm sure you've looked at it, and I know you guys have already been talking about how to split things up. So now that you've seen that WCF application, that should give you a kind of fill in some of the blanks, some of the questions that you might have had about this project. So like I said, you're kind of a mailboxes store, and you're going to allow people to walk in your front door with packages, and you're going to give them the option of either 2-day or overnight. Then they're going to also have the option for different carriers. They can do UPS, FedEx, or USPS. Now, I don't want you to write interfaces that actually connect to these providers, which you could, I know you could. I want you to write the interface that determines what the cost is going to be. So in your service, you might have something like, you know, if the shipping is UPS, make it, you know, $2 times the area of the package. But you can have some hard-coded values like that in your service where you're just returning different amounts depending on what choices were made so that you can validate that your service code is working properly. So if somebody puts in a package that is, you know, 47 pounds, make it be a different price depending on which service they choose, and make it be a different price depending on whether it's 2-day or overnight. So some sort of formula that just generates data is what our service needs. You should have a form. So this should be a forms-based project, and it should start out at allowing the customer to choose which company, which shipping method, and how heavy the package is. You're going to call then a web service that will return the cost for this package. They should be able to ship multiple packages using different carriers and methods. When a customer is finished, an invoice should be generated to show each line item, a subtotal, the tax, and the final total. The program should allow the customer to print the invoice to the printer. The program should allow you to print the shipping labels for each package on the order. Invoices should be saved in the program so they are viewable on demand. The current day's invoices should be stored in memory, while older invoices will be serialized and saved to the SQL database for later retrieval. Okay, so lots of areas here where you can make some design decisions. When you start out asking for the customer information, you're going to want to get some addressing information so that you can print the shipping labels. So you probably only want to get the customer's addressing information once, right? If you came into a store and you had to type all your information and then add a package, when you added the second package, you would probably like to not have to retype all of your address information again, but you would expect to need to type in information for a new customer. Now, as they're entering their information, you can have it work however you like, but when it gets to the point where they're coming up with the cost, you're going to call your web service. This web service, a lot of times, I think I mentioned to you guys a couple weeks ago, a lot of times project teams will think that this is the big part. It's not. It's a really small part. So don't make this one person's only task. It's way too small of a part. It can be handled with many, many other tasks because we just saw it's pretty easy, right? It's just that the method is contained in a different class that runs in a different way than a normal one. So that is not a one person task item, or not their only task, I should say. If I'm using this system, I should be able to say for package number 1, I want this to be the United States Post Office and it's 7 pounds. Package number 2, I want it to go FedEx and it's 20 pounds. You can handle the other stuff, the addressing, however you want. Now let's look at an invoice. You've seen an invoice when you buy something from Amazon, right? So an invoice is going to start out with some header information, like the invoice number. That can be something that you guys sort of decide how you want it set up. You might have something in your database that keeps track of what the next invoice number is, or you might just randomly generate it. It's up to you. Now, in your invoice, what the important thing is that you should have an item here for each package. So you don't have to list all the address information and everything for each package on this invoice. You can't fit that. But you could say package number 1, you know, the weight and the cost. Package number 2, weight and cost. Those kinds of information on your invoice. You're going to have a subtotal. Your task is going to be, again, some sort of method that returns a calculated value, however you want to set that up, you know, 0.007%, you know, 7% or something like that. And then your total. Now, generating the invoice and doing hard copy print is going to be difficult. It's not something that Visual Studio or C# makes easy. So this invoice that you generate can be very, very rudimentary, okay? It doesn't have to be fancy like this one with watermarks and things like that. I want you to work with your group to determine what kind of printing capabilities are there that are available, which printing capability would be the best to try, and kind of get some basic printing going on. So that's what we're trying to do with this one. So you won't be counted off if your invoice is not beautifully perfect. Your invoice, however, must have a line for each of the packages that were shipped. Now, once that invoice is printed, or you know, your function that generates the print can be completely separate from the function that saves the invoices. So this wording down here is kind of confusing. It says invoices should be saved in the program so they are viewable on demand. The current day's invoices should be stored in memory. What that means to me is they should just be in a list box or something on the screen. Okay, there's some sort of array, like a list in memory of the invoices that have been entered so far. On the screen then, there is also a button that says save days invoices, you know, save these invoices. And that button is what serializes and saves each of the invoices on the list so far. Does that make sense? So they get spit out into that database. Now, notice that it says They're going to be saved to the database for later retrieval. You do not have to implement that retrieval aspect of the application. Now, I've had a lot of students over the last few years that have, because they've already had everything in place. They just went ahead and made it to where when the application starts up, you could choose an existing invoice if you wanted to, but that's not a requirement. Getting them saved is all, that's the requirement. So you have some decisions to make. How do you want to set up your database? You have a shared database that's been set up on the server for you to create your tables that everybody in your group should be able to access. How do you want to set up your database? Do you only want this one table that are serialized invoices? Or do you want to set up a table that's like next available invoice number that has an identity column that generates an invoice number for you? How far do you want to go? That's going to be up to you and your group. So you see the requirements. Yeah, Rich, this should be SQL based. Other questions? Just let me know if you run into questions as you're working on it. Looking at the UML, we should have a package class. And then the recommendation is to extend that package class into a 2-day package and an overnight package class, an invoice class, and an iPayable interface that is actually our service. So that calculate cost method would exist in that iPayable service. Yeah, Mary, there should be a common database for your group. Oh, Mary is answering. Sorry. Thank you, Mary. Yes, you guys should have a common one. So in this example, the invoice class is the class that is associated or that implements the iPayable interface. It's got this other weird line here too. So if you determine that you would like to modify the UML, that you're going to add or change things, that's fine. Keep track of that in a document so that you could explain if you needed to why you decided to change it. Any questions? Let's look at the database there. Rich sees them good. They're there. That 10 or 12-day vacation has me all whacked out too, because I'm like, let's make sure they're really there. I think I remember creating them all. So as far as security goes, each person in the group should be a database owner. That means you need to be careful because you could, mess stuff up that everybody else did. So the groups are set up with security that way. In TFS, you also should have a separate TFS repository for your group. And I am on the portal here. And if you're using Visual Studio, when you connect, you should see them. Where are they? There they are. Again, it should be CIS151-G01, G02. The first person that uses the TFS repository then will need to create the project. You guys could have multiple projects if you wanted to in your TFS repository. But here for group one, we would say like shipping project. We would make sure that our version control is set to team foundation and then create. And that would create that entry point for us to use in Visual Studio. You know, I don't know if you can do that within Visual Studio. Let's everybody get that done real fast here while we're together. So go to a web browser. I know, Jackie. I was worried about everybody coming this morning because I thought, it's going to be so hard to get back on track. And this is like our last day of being on track. So in your web browser, go to cisteam.otc.edu. Remember that one has to be HTTPS. So if it's not finding it for you, you might need to actually type in the HTTPS:// thing. Now, once you get to that cisteam.otc.edu, we want to log in using your standard OTC credentials. Then up here at the top left corner, there is this drop-down list, and that's TFS repositories. So in that drop-down list, you should see your personal repository and you should see your group one. So go to your group one and create your new project. Just make sure you use Team Foundation Server for your version control. We don't do this creating projects very often, and I didn't have you do it in the first semester, so definitely wouldn't want that to be a barrier. Oh, there's one. Group 5's got theirs. Good job. If anybody's having trouble with it, let me know so we can get you on the road to success. That's one big thing about this group project. I know that at this point in the semester, you guys are all really good at using that grade tool in Canvas, or at least I would be. Let's see, if I don't do this project at all, 0, what's my grade? And I know that we do a lot of assignments, so one assignment doesn't matter. But this project is going to give you so much self-respect. Is that a good way to put it? You'll be really proud of yourself for getting it all done. So work on it. Now, if we have any problems with groups, please let me know, because we do have some small groups. So we could definitely combine some forces if we need to, or anything like that. So we can get that done. But there is security involved in making those kinds of changes, as you can see. So we want to make sure and get those changes made if we need to. I'm going to shut up now and let you guys work with anybody who might be having problems getting the service up and running. So let me know, and otherwise I'll be here.
I noticed that there were two different. Yeah, there were two different ones. Yeah, and so I wasn't sure. I was asking them which one we should use.
Yeah, that's good.
Because I've got.
They both created one. Okay, but it's letting you see them all.
Yeah, it lets me see them. So.
Because it's like, I'm not exactly sure what level that security is set up.
Yeah.
But you guys will have that.
It looks like
First decision. Let's see how they handle that. Okay, Jackie, can you go back to that and go up to the top again? Gosh, the ones you need are there. Hang on, I'm going to do some searching. Yep, that's the one we need. Yep. I would imagine I'm going to let you shut everything down because you're probably going to need to end this Zoom session to get that to download. So yell back if you have any trouble. We'll be here.